Okay, in this one I wanted to show a little hidden feature of C++, at least I think so, which is new with placement. So you probably all know the regular new operator. It's basically malloc and free. I mean, new and delete are malloc and free for the most part. And so if you want a pointer to an integer, you do equal new int, and then here you can initialize it, and then now you have a pointer to a pointer to an int, and then at some point you need to delete it, and this is basically your thing. But what I didn't knew is that the new keyword can take what's called placement arguments. And so here you can basically specify a buffer where to allocate the memory. So by default, it uses just heap allocation, the new keyword, just like malloc and free again. But if you already allocated the memory, let's say with your own allocator or with a let's say you have a collection, like you write your own std vector or your own map or whatever, you already allocate the memory inside of your container. And so when you want to construct an object on it, you would like to avoid like copying bytes around, and when you construct the object, you already know where it's going to end up in memory, so you just want to say construct it at this memory address, and this is basically what this does. And so in my little example, I have here an array of 32 bytes, as you can see, and I fill them with 0. And what I can do is I can do int, let's say a new with placement, and I specify buffer, and I say I want an int, and let's say something in hexadecimal so that it's very visible, something like this. And now you can see that my integer was allocated inside of the buffer. So I don't know if that's clear, but yeah, you can see that instead of 0, you basically have the integer which is stored in my buffer. And so if I want let's say another one, I would do buffer plus size of ints, like so, and this I would call b, and I would do abc, something like this. And you can see that now I have my other integers stored next to it. And everything is allocated inside of the buffer. There was 0 heap allocation. And so yeah, that's pretty much it. There is a few caveats though, is that you cannot really call delete on it. You have to manually call the destructor if your object is more than an int or a double and it has a destructor. So let's say struct foo, which has let's say an integer, and it will have a destructor like so. That will just print something. Foo destruct like so. And now if I want to let's get rid of this and make a foo pointer, this will be foo like so. And you can see that here I got no print of a foo destructor. So what I have to do is when I'm done with the object, I have to call the destructor myself, like so. And here it's destructed. And also if here I do a is equal to 242, you can see that indeed foo uses the memory of just the buffer that we gave it instead of a heap. And so yeah, that's basically it for newest placement. I think it's going to be very rare if you ever used it, but it's just a cool thing to know, you know. But yeah, and the fact that so if you have the cool thing about it is that if you have a constructor like so, and we would initiate a to be x times 2 or something like that, you could use the constructor here inside of the new, and so basically it would instantiate foo directly in the buffer instead of making a copy, then copying this in the buffer. So yeah, that's about it. The use case where I wanted to use it was I had a message queue system between my thread at work, and basically whenever you send a message, you have to pre-allocate some size for the the message buffer. And I thought I have like objects to pass around in the queues, and I thought, well, might as well like save a copy and just use new with placement with the message buffer. Turns out it doesn't really work, because if you're because I wanted to avoid like passing pointers around and so on, but if you have a std string in there, you have a heap allocation anyway, so it wouldn't save much. But anyway, that was my use case. I think it's mostly useful if you're doing like collection stuff, like if you're implementing mplace, if you know about it, for your collection, or things like that, or your own allocator, of course. And a neat trick, a neat things that I found, like this is a thing that probably like one person over 10,000 will use ever, but actually there is a new operator. You know that C++ likes to have operators for everything, and there is a new operator which I knew about. And it's basically, if you change the new operator, you will change the global allocator that everything uses. And that's fine, like it takes a count and returns you a pointer to, I guess, an allocation of count size. But what I didn't know is that, for example, this is the overload of a new. If you use new with placement, like I just did, like it will call operator new with the count, so the size, and the pointer to the buffer. But what I didn't know is that you can create your own operator new overload. And so I have no clue why this would be ever useful, but it's just kind of cool of thinking that you can specify anything there. I could have an int and a double if I wanted. Of course, it won't work here, but let's say here in the error, we can see that using this line, the new with the parentheses and so on, you can see that it says operator new size type with the buffer, an int and a double. The overload doesn't exist. But I haven't actually tried this, but let me try to overload the thing. Okay, I just tried it and it worked. So if you create your own operator new with your overload, so in my case it's like a pointer to buff, an int and a double, it will actually just use your overload new, which, yeah, again, I have no idea why you would want to do this, but it's kind of neat. Like you can call new with any argument you want. This is just very strange syntax, but I kind of like it. So yeah, anyway, that's all I've got for today, and see you in the next one.